In this section, we're going to be looking at calculating the molarity for a solution. A solution is made up of two different parts: the solute, which is the thing that is being dissolved, and the solvent, which is the thing that it is dissolved in. An aqueous solution is one in where the solute is dissolved in water. Most of the solutions that we'll be using this year are aqueous solutions. When we have a solution, we can qualitatively describe it as concentrated or dilute, but those terms can be a little bit relative. So often we want to know exactly how concentrated is my actual substance. And one of the most common units that we'll be using to do that is molarity. The formula for molarity is the moles of solute divided by the liters of solution. It is very important when you are doing these questions that you never round an intermediate result. Always wait until your final answer to round. Otherwise, the rounding is going to exponentially increase how far off you are from your actual answer as you continue doing more and more calculations with rounded results. A 335 milliliter soft drink sample contains 0.133 moles of sucrose. What is the molar concentration of sucrose in the beverage? Well, the formula for molarity is moles of solute, 0.133, divided by liters of solution. Here we have 335 milliliters, so we do need to convert that to liters first. So 335 milliliters is 0.335 liters, and then when we divide, we get 0.397 molar. And this is my final answer because all it's asking for is the molar concentration. This question is asking about grams. Grams isn't part of that equation, so we're going to have to do a couple of steps to get our final answer. So this question says, how many grams of sodium chloride are contained in 0.250 liters of a 5.3 molar solution? Well, molarity, 5.30 molar, equals moles of solute, which isn't what I'm looking for, but I can convert from moles to grams, divided by liters of solution, 0.250 liters. When I solve this, I get X is equal to 1.325 moles. But I'm not looking for moles as my final answer. I'm looking for grams. So I need to find the molar mass of sodium chloride, which is 58.4 and a couple more decimal places out. And depending on which periodic table you're using, you might have slightly different answers for the molar masses. But you put the molar mass over 1 moles, the unit of 1 mole, or the unit of moles cancels out. 1.325 times the molar mass of sodium chloride gives you 77.4 grams of sodium chloride in this sample. The other thing that we can use molarity for, and one of the reasons why molarity is a really nice equation to, or nice unit to use, is we can calculate the concentration of a solution if we dilute it very easily. So the equation for that is C1V1 equals C2V2, where C is the concentration of the solution in molarity times the volume. And the volume can either be in liters or milliliters as long as it's the same on both sides. The reason this equation works is when I dilute a solution, I'm adding solvent to it, but the amount of solute doesn't change. And if you take that molarity equation above and solve it for moles, it's the molarity times the volume is equal to the moles of solute. So we're essentially using that property, although the volume can be in either liters or milliliters, because if I plug it in milliliters, I would be doing the same thing to both sides, dividing by 1,000 to get it into liters. So you will end up with a valid answer if you plug in milliliters for the volume on both sides. The reason dilutions are so important is oftentimes we have what's called a stock solution, which is a concentrated solution that is kept on hand in a lab supply room. Instead of saving 10 different bottles of different concentrations, we have this stock solution that we can then dilute to whatever concentration it is we need to use for a particular solution or for a particular experiment. So here I have 0.850 liters of a 5 molar solution of copper 2 nitrate, and I'm diluting it to a volume of 1.8 liters by adding water. And I want to know what the molarity is for the diluted solution. Well, C1V1, the initial concentration is 5 molar. The initial volume is 0.850 liters. So C1 times V1 equals, I'm looking for C2, and it says I've diluted it to a total volume for my solution is now 1.80 liters. And when I solve that for X, I get 2.36 molar. So when I take this 8.50 liter sample of 5 molar solution and dilute it to 1.80 liters, the concentration of the resulting solution is 2.36 molar.